In 2011, NASA's Messenger probe first entered Mercury's orbit and took some mind-blowing photos. Because on a planet that's so hot that lead melts here, Messenger found deposits of billions of tons of ice. How is that even possible? Interestingly, despite Mercury often being closer to Earth than Mars, it's been explored the least among our neighboring planets. What else does this mysterious world hide from us? In this video, you'll discover where life could be hiding on Mercury, how it threatens all life on Earth, and how this planet can provide future humanity with endless energy. And in general, what secrets about Mercury will turn everything we know about it upside down? In reality, Mercury is perhaps the trickiest planet to investigate. This is even though 2,000 years before our era, the Babylonians observed Mercury and included it in their star catalogue. They were extremely surprised that Mercury occasionally seemed to move backward across the sky. The Babylonians couldn't explain this weird phenomenon. Later, ancient Greeks noticed that Mercury moved faster than other planets, so they named it after the swift-footed messenger god Hermes. His counterpart among the ancient Romans was Mercury, in whose honor we still call the planet. Only in the 16th century did Galileo Galilei finally explain Mercury's peculiar motion. It revolves around the Sun much faster than the Earth, causing it to pass us several times a year. This creates the optical illusion that Mercury is moving backward. This is the same retrograde Mercury that astrologers baselessly blame for all the troubles in your life. Galileo cracked this mystery thanks to a groundbreaking invention, the telescope. But due to the planet's proximity to the Sun, studying Mercury through magnifying lenses was incredibly tough and even risky for the eyes. Even the mighty Hubble and James Webb telescopes today hesitate to point their gaze at the planet closest to the Sun because their equipment might not be able to handle its flares. So, should we just launch a spacecraft to Mercury? Actually, it's not that simple. To get closer to the Sun, any probe needs to significantly slow down. So, for the Mariner 10 probe in 1973, they devised a complex orbital route to break around Venus. The craft only reached Mercury's orbit the following year and orbited the planet 3 times. It captured the first photo of Mercury's surface, which, with its craters, strongly resembled the Moon. To scientists, this gave rise to the theory that they shared a cosmic ancestor. But a chemical analysis of their surfaces showed that Mercury and the Moon are entirely different. The real surprise for scientists was that Mercury spins around the Sun entirely differently than the Moon around Earth. Typically, a smaller celestial body at a short distance from a larger one always turns one side toward it. But Mercury does rotate on its axis, just incredibly slowly. So slowly that a day on Mercury lasts a whopping 176 Earth days, twice as long as a Mercury year, which is 88 Earth days. That is, one day on Mercury lasts 2 years. Wrap your head around that. And Mercury has more surprises up its sleeve for scientists. See these tails glowing from Mercury like someone signaling us with cosmic spotlights. They've been a long-standing mystery. Could Mercury really be a giant comet? That'd be absurd. Before the Mariner 10 mission, scientists thought a planet 1/3 the size of Earth simply couldn't have a magnetic field. Observations from Earth telescopes backed that up. But the spacecraft indeed detected a faint magnetic field capable of causing magnetic storms, yet weaker than expected. And it's precisely these storms that attract hot solar wind plasma to the planet's surface. Hitting Mercury's surface, it pushes neutral charged atoms upwards. It's like water splashes during a jump into a pool. That's how those quirky comet-like tails are formed. But where did a magnetic field come from on tiny little Mercury? It can only exist due to circulation in the molten metallic core. But how did such a small planet keep it when even a planet twice as large as Mars is almost entirely cooled from the inside? During the latest Messenger probe mission, scientists found out that Mercury's core is abnormally huge, occupying 70% of its mass. Earth's core, in contrast, is responsible for only 1/3 of Earth's mass. This explains why Mercury hasn't cooled from the inside yet, but creates a new puzzle. How did it get such a colossal core? According to one theory, billions of years ago, a massive celestial body collided with Mercury, causing it to lose a substantial portion of its outer rocky layers. But recent studies suggest that the responsibility for Mercury's large core lies with the Sun. Back when our young star was surrounded by gas and dust clouds instead of planets, its magnetic field was pulling in iron particles. So the closer the planets formed to the Sun, the more iron they had in their mix. That's how Mercury managed to grow such a disproportionately large core. But this planet's play with our expectations was just beginning. Mercury has things it shouldn't have. Studying images of its surface properly, scientists saw that it's entirely covered with large rocky formations resembling steps in a landscape. They stretch for hundreds of kilometers. The longest of these rocks reaches 1,000 kilometers. According to the leading theory, this is a result of the gradual cooling of the planet's core. It shrinks and wrinkles, similar to how grapes turn into raisins when drying. However, scientists believe that if these rocks appeared only due to the core's reduction, they would be evenly distributed across Mercury's surface. Instead, it turns out that most of the rocks are concentrated in two bands on opposite sides of the planet. Some scientists speculate that this relief is due to the expansion and compression of the mantle layer, while others believe it's too thin for this. What stumps scientists even more is that there are twice as many rocks in the southern hemisphere than in the northern. Explaining this anomaly is currently mission impossible. To shed light on this mystery, the BepiColombo probe was launched towards Mercury, set to approach the planet in 2024. The first distant photo taken by the probe only added more intrigue as it clearly showed new Mercury wrinkles. So check this out, the smallest planet in our solar system keeps on shrinking. And it seems like it's not just about the core cooling and squeezing. Chemical studies showed that Mercury is loaded with volatile substances like water, sodium, carbon dioxide, and mercury. Over time, these compounds vaporize through the surface and theoretically could be creating these new young rocky formations. But the high concentration of light materials on Mercury is a real head-scratcher. I mean, the Sun should have evaporated them ages ago. So how did Mercury manage to hold onto its volatile riches for over 4.5 billion years? One explanation suggests that this planet actually formed much farther from the Sun but eventually hitched a ride closer due to some gravitational pull. According to one hypothesis, Saturn's gravitational influence caused Mercury's migration. Hold up, didn't Mercury need to form close to the Sun to have that big metal core? Something's not adding up. And add to that an abnormally large amount of water ice. Even though temperatures on Mercury can soar above 400 degrees Celsius, it's not that surprising that remnants of ice can linger deep in crater shadows and at the planet's poles. But get this, scientists found there's more water on Mercury. Where does all this water come from on one of the hottest planets? Paradoxically, water on Mercury might appear thanks to Sun activity. The planet's surface contains linked oxygen and hydrogen atoms, known as hydroxyl. On their own, they can't form water. But protons from the solar wind can penetrate Mercury's surface where hydroxyl hides. This activates linked oxygen and hydrogen atoms, making them slam into each other, forming water molecules in the process. Some of these molecules evaporate through the atmosphere into space, but the rest manage to land on shaded poles and settle as icy formations. And even though this process is pretty slow, scientists estimate that in 3 million years, Mercury can accumulate nearly 10 trillion tons of new ice. That's like 46 Columbia Glacier in Alaska. So, does this mean colonizing Mercury will be easier than Mars? Especially since Mercury gets 6 times more sunlight than Earth and could easily power a colony for centuries ahead. And not just one. So why aren't we there yet? In fact, settling on Mercury is not the best idea. Though scientists are eyeing Mercury as a cosmic solar power station for humanity's future needs, the road to that is far from smooth. The Messenger probe took 7 years to enter Mercury's orbit. It orbited Earth, Venus, and Mercury several times to slow down enough. Would you sign up for spending that much time on a colonization ship? Landing on Mercury won't be easier than getting there because it has almost no atmosphere to help slow down a spaceship. It could be the trickiest parking job in the world. And the extreme temperature swings from -180 degrees Celsius at night to 400 degrees Celsius during the day will either fry or freeze you. Here, the colonist will find solace in the duration of Mercury's day, which is 176 Earth days. This will help determine the time and place for landing at a relatively safe temperature. But still, Mercury can throw you a curveball because due to its unique orbit, the sun can rise twice in a row. So even if you land during a warm sunrise, you should still be ready for chilly dusk. And if your spacesuit shorts out from the temperature swings, you're in for a rough ride because Mercury's low gravity creates almost a vacuum. This will literally tear your lungs apart, and your blood will start to boil. In 15 seconds, you'll lose consciousness due to lack of oxygen, and your fellow colonists will have about a minute to save you. So, spacesuits should be well adapted for the harsh Mercurian conditions. And it'd be great if they are suitable for mining, as you'll have to do a lot of digging to survive. During the Messenger mission on Mercury's surface, scientists found abnormally high concentrations of valuable resources. These are pure metals, which we struggle to extract from their ores on Earth. The first colonists to mine Mercury will essentially be like extracting ready-made metal bars. And because of low gravity, such mining will be easier than on Earth. This will help scientists quickly build solar batteries and future bases. But the solar batteries themselves will be very expensive. Landing on Mercury and returning from it is so challenging that the first colonists will have to wait quite a while for new arrivals. Even if we send ships to the Sun's nearest planet on an ongoing basis, the average time between Mercury flights will still be longer than that between Mars flights. So you'll need to adapt to Mercurian life as soon as possible. And for that, you need to find a place where the day-to-night temperature difference is less extreme. Scientists believe that if a person settles in a crater at Mercury's poles, they could survive there longer. Temperature there never rises above 0 degrees Celsius, and there's ample water. The main catch will be how to extract that water from under a multimeter layer of dust. Future generations of colonists could also engage in building small greenhouses in craters. The increased amounts of sunlight and water would allow for plants to be grown much faster. But who knows, maybe even simple bacteria will beat us to it. Scientists found out that several types of bacteria can withstand heat above 120 degrees Celsius. That means they can survive on Mercury during its day if buried under layers of dust or even in a rock. And if they get access to icy water on the poles, they can colonize the entire planet. Studying Mercury's microbial life can shed light on the cosmic migration of species in general. But meanwhile, this planet threatens to destroy the Earth one day. According to computer models, Mercury's orbit is unstable in the long run. Every couple of billion years, this planet can be ejected from its current orbit due to a gravitational clash with Venus, Jupiter, or even our Earth. Or Mercury could be thrown closer to the Sun or out of the solar system altogether. But in the worst-case scenario, this planet can collide with the Earth in 4 billion years, causing destruction comparable to the fall of the Moon. It seems that the more we know about Mercury, the more mysteries we uncover about this planet. With every new mission, we're discovering more interesting facts about our distant neighbor. So who knows, maybe one day the sky over Mercury will be lit up by its first human settlement. If you found this information captivating and want to explore more about Mercury and other intriguing celestial phenomena, make sure to follow for future updates. And don't forget to check out our previous episodes where we dive deep into the wonders of the universe.